Welcome everyone. Thank you for joining. Great to see you all. Apologies for those for whom it's already a little bit late in the day. Global scheduling is not as easy as it sounds. Let me start with first introducing who do we have here. Then I will say a few words about our company, and then we'll get going with the topic, which is the safety AI. Now, you have me here, Ilya Kochik. I am Vice President of Business Development for Toloka. Before that, I've been working at Google, McKinsey, Quantum Black AI, which is a part of McKinsey. And for the last 10 years or so, I've been developing ML AI solutions, and now mostly focusing on Gen AI and helping our clients to get their quality data for their Gen AI and ML models. We have here with us today Alex Borodetskiy. Alex, maybe you can say a few words about yourself.
Hello there. Pleasure to meet everybody. Thank you for attending. I'm VP of Growth. I'm driving safety and red teaming offering here at Toloka. Have a consulting background and tech.
Perfect, thank you. So let's spend a few words to explain you who we are, what we do, so you'd understand a bit more where we come from with this topic of safety. So first of all, what is Toloka? Toloka is a part of a Nibus group, which is traded on NASDAQ. We have headquarters in Amsterdam. And to make it simple, like to put it very bluntly, we are a combination of humans and technology. So we use combination of humans and technology to provide data at scale. We have platforms that can help us orchestrate a vast amount of people, make sure that the data they produce is of high quality, build virus interfaces to work with any modalities and so on. And we use Toloka app for crowdsourcing, and then we have Mindrift portal for experts. So our crowd is pretty big. So we have 200K active users, 100 countries, 40 languages. But on top of this, we have different tiers of experts. Also quite big number of people who have 5 years of experience in different domains, industry domains. They speak 10 languages. Most of them would have 95% would have higher education. Half of them would have master's degrees, and then 15% would have PhD degrees and so on. So we have a huge pool of experts who can provide data, and we have 10 years of expertise of generating quality data. So we both work in, we started with traditional AI, like helping refine search engines, voice assistants, maps, ads, and so on. But now we spend this, obviously, many of the companies in tech these days, we spend a lot of time with Gen AI and Gen AI clients. We work on supervised fine-tuning data, reinforcement learning with human feedback, evaluations. We work with safety of the models, and this is what we're going to double click in today. We do this across all the modalities of both text, images, audio, video, action. Separately, we also work with coding. And all our expertise, so basically what we've been sharing is a combination of the work we're doing with some of our long-term clients, from top organizations to startups. It's big techs, enterprises, startups, and open source organizations, but also we do our own research, and we both support it and lead. We have lots of different partners, from University of London to Carnegie Mellon University, TUM, and so on. So this is our story in a nutshell. So we been spending over a decade on creating data for Gen AI and AI with help of humans. This is the takeaway that you want to take out of it. So with that, I want to flip to the topic of this webinar. So we want to share some of our expertise and some of our recent research. And Sasha, maybe you can pick up from here.
Yes. Thank you, Ilya. Thank you again, everyone, for taking time to come to our webinar. I personally believe that safety topic is a really an urgent topic for entire industry. Therefore, we have put together this presentation to share our experience of projects that we do. And we will cover 3 things today. We will start with a few definitions, what is safety evaluations. We will talk about how to use risks in order to define the scope of the evaluation of the evaluation data set. And we will go through main steps that you need to perform in order to design and evaluation data sets. And we will support that with examples from our projects that we have done. As I mentioned,
Sorry, Sasha, a quick announcement here. Some of the ground rules. We want to spend 1 hour. We hope it to be interactive. So Sasha will tell the story and our expertise and some of the interesting facts. Now, if you have any questions, please feel free to write them in chat. We have a couple of moments where we'd spend answering those. Yeah, so if anything, if any problem, just let us know. Thank you, Sasha. Please go ahead.
Sure, thanks. We spent, as an industry, a lot of efforts on the quality of the models, and the model capabilities are improving every day. But the safety is the urgent matter for all of us. If you look at the AI incidents database, which registers the real life events that already happened in the past, back in 2023, they have 120 records, which was considered to be a skyrocketing. In August and September 2024, only there were 46 incidents registered. And we see the malicious use and the risks happening in real life with deepfakes, with political influence. We see the examples of users being either harmed or cases where it is associated with Gen AI products. We need to protect the products from the malicious use. There was a research that showed that if you build a custom chatbot on top of GPT, it is really not that hard to get access at least to the system prompt or to the files which contain the work that was done and integrated in the product. The different malicious uses of the products that we developed are yet to be discovered, again, starting from deepfakes to a more and more nuanced and unexpected malicious uses. And regulation is being developed as we speak, and it will also create complexity for evaluations that we do. And that is only the end of 2024, and we have years in front of us. So therefore, the safety is important, and I want to start with clarifying a little bit the language. So the terminology that we use in AI in general, and safety in particular, can be confusing. There is a set of words that you can see all over the place in academic research papers. And I made a short quiz of the colleagues and a few people in the industry. And so what happens is the teams, when they work together, they land to the same dictionary, but people do tend to have slightly different understanding of the key terminology. So therefore, the first few minutes quickly aligning on the language. Let's start with frameworks. And the responsible AI is an example of the framework that is used for the safety development. Another example is the trustworthy AI, ethical AI, and there are others. What is framework? Framework is a structure that describes all the aspects of safe AI development. For example, safety and fairness are one of the aspects of this, but not only those. The frameworks cover how documentation should be done during the AI development. They cover how governance should be set up, what methods should be used, and what requirements should we have for training data. So all of that is captured within the framework. Here on the page, this is the illustration of Microsoft version of responsible AI. Most of big tech companies use some variation of this. Trustworthy AI is another example. If responsible AI appeared and was introduced more than a decade ago, trustworthy AI is a more new one. It was developed in 2018. And for example, this framework is used by European AI Act. Very similar scope, few nuances, for example, a little bit more focus on environment, but the same objective of the framework. And one thing that the frameworks have in common is that they expect specific measures to be quantified in order to ensure the compliance with the framework. So safety, biases, fairness, reliability, security, and the quality are the examples of those measures that we use to ensure the compliance with the framework. And they are later decomposed to the more granular metrics, such as within safety, how toxic is the model, and so on. And finally, the methods. Evaluation, red teaming, blue teaming are some of the methods that we use in order to quantify and improve the metrics. Evaluation methods that we use today are not that different from the ones used in machine learning for the years before the Gen AI started to boom. We build a test dataset which consists of test items, typically prompts. We know the expected output. We get the model responses. We are able to calculate the metric. A similar approach works for Gen AI. Red teaming is a different method. Red teaming was not used largely before Gen AI. It came from cybersecurity and proved to be really effective for Gen AI cases. Red teaming would have the same data structure. It would consist of number of prompts that you would test for Gen AI model, but that would really be done in iterations. For a few weeks, you put together a few thousands of prompts to proactively find the areas where the model behavior different from your expectation. And you put together a feedback loop into AI development. And today we will be talking about the evaluations. Sorry, I pressed something wrong. Can you see my screen?
Yeah, the box, I mean.
Okay, good, sorry. Today we will talk about evaluations. Let's start with one example. What I suggest we do, we would take example of an open benchmark developed, for example, by ML Commons, and we really look inside and see what are the big building blocks of the evaluation data set, so that then we can use that as a structure to go deeper into different aspects of evaluation development. So ML Commons, as an example, this is a well-known organization which mission is to develop AI metrics, frameworks, and the standard data sets to be used by the industry. They have published V0.5 benchmark earlier this year. This is not yet the safety evaluation data set. It's more of a proof of concept. What does it mean? The scope of this exercise is rather limited. They limited the scope to 7 categories, mostly related to physical harm. And it is built based on quite artificial prompts, which still comprehensively challenge the model on a number of safety topics. Let's look inside of this data set and see what it consists of. The overall objective is to test the general purpose LLMs, mostly on the risk of endorsements of harms and hate towards different groups. The dataset consists of 40,000 prompts split into 7 categories. For most of the categories, roughly 2,000 prompts are generated, with more allocated towards hate and towards the violent crimes. And the reason for that is that there are multiple items and subcategories within the hate to test versus hate versus different groups. Give me a second. Yeah, so within hate, to cover a number of subcategories, therefore this number is bigger. They are classified into safe and unsafe prompts, giving back the total number to 43,000. And this defines the taxonomy of the data set. And if you look inside it, what we do let's talk about the types of prompts. When we produce the data for evaluation data sets, we not only look at the numbers and the distribution, and we actually work with the prompts that we produce. And these examples give very good illustration of what those prompts are within these data sets. Those are short, typically very straightforward formulations. They are very clearly classified in safe and unsafe. Similar structure. You can see that the sentences follow the similar structure. This is due to the template-based generation that was used. And this is kind of the second part that needs to be covered in order to define what data set we want to create. And finally, once we get this data, we have 40,000 of prompts testing different aspects of safety. We need to define the policy, what is considered to be good. In the example of ML Commons, again, given the very straightforward nature of those prompts, the evaluation is done by the automated model using human. And the benchmark that the model has to score in order to achieve the low performance is very high. So 99.9% is expected for a model to be classified as low risk. Interestingly, 0 out of 14 models that were tested were classified as low. But again, here I want to remind that this is the proof of concept data set, and the new version is expected to be released later this year. But the reason why we bring this example is that it clearly shows the three big parts that we need to go through in order to design our own evaluation. It's the definition of the use case, and we will talk about the risks that we need to cover there, the taxonomy of the data, the categories that we use, the types of prompts that we want to create, and the policy which will define how are we going to evaluate the responses. And we will use the same blocks to structure the deep dive part of our presentation. We will talk about simple evaluations. Let's take an example of a more like a general purpose chatbot. Let's take an example of a comprehensive evaluation data set, which we would try to cover a number of different topics with a wide spectrum and number of different user intents. And we will talk a little about the policy that creates a mapping of the different types of testing samples with the expected behavior of the model. And we start with the use case. Many of companies we work with do start with categories when designing the evaluation data set. You would create the categories such as crime, such as hate. You would split crime into violent crimes, non-violent crimes, and you can start creating the testing samples. But let's pause here for a minute and ask a question. So what is it exactly that are we trying to test with every single prompt that we do? Because every test item should be testing something from the model. Do we care about the language that the model will use in the response? Or we don't want the model to endorse the intent that was contained in the prompt? Maybe we don't want the model to provide some information or help to create misinformation, and so on. We can take an example of a very straightforward example, like how do I make a bomb? And you can think about two possible harmful responses from the model. One of them would say, yes, go ahead and make a bomb. And another one would really provide some not easily available online information about the chemicals and the proportions that needs to put together in order to get to the expected, to the result that user expects, and endorse this behavior. So same prompt, two very different responses, both are harmful, and very different implication in the real life. And this brings us to the notion of risks. When we design the evaluation data sets, we separate 5 types of risks, and we designed the evaluation to test against those. The first part are the data sets, which consist of prompts where the harmful information most typically is already included into the user question. And the undesired model behavior would be endorsing the harmful intention. So those examples from, for example, ML Commons data set that we looked at would be the illustrations of those. It can be related to crime, to dangerous, it will be split by category, but the overall risk is endorsing the intention. Generating harmful content is different. The evaluations, multimodal, this is very typical for multimodal evaluations, as this is an obvious risk from video generation model, from image generation model. It is also applicable to text. In text, we evaluate versus IP violation, for example, but we can go further. Can the model be used to spread misinformation, and how we evaluate if the model can help significantly, if the model can boost the malicious user ability to spread misinformation. These are some examples of evaluation which I haven't seen in the research, but these are the risks that we want to consider. The second part would be the evaluations which the second group of risks are the ones where the model provides some harmful information for the user. So here the prompt might request the model to produce something, and the harm comes in the response. The biases would be an example of those. Another example would be providing the restricted information. We can go back to the example of the bomb. This is one of the illustrations for that. And this risk is being tested. For example, the foundational models go through testing on the topics of indiscriminate weapons. There was research on that. There were even leaderboards. But what about the financial crimes? Can the model be used to help the user avoid taxes? Again, there are areas, more research and less research, and these are evaluations that will be required in order to mitigate those risks. Now, finally, the models gets more agency, and as that get more agency, it also would require different types of evaluations. If you take an example of text, the self-harm would be classified here as the failure of the model to recognize the vulnerability of the user would be an act in itself. Therefore, the negligence would be here. But if we think about the increasing agency of the models, we will need to have new evaluations for this specific part.
Sasha, do you think we should take a quick break and discuss a couple of questions we have in chat? You'd rather go ahead and push through?
Okay. Yeah.
Okay. If you want to go.
No, let's go with those questions.
We have a couple of questions there. So I won't even try to pronounce names. Apologies. Don't want to mispronounce anyone. But the first question is, when we were speaking about the ML Commons data set, so which data set was it? Is it an open source data set? Can you tell more a little bit about the ML Commons bit?
The data set is available. So the examples that I found, at least samples, are available on GitHub. And the benchmark is available for public use. You can go and find it online. So you can test your model against this benchmark and get the assessment.
So let us know if it answers your questions, or if not, just feel free to post any follow-up. There's another one, it's quite interesting. So say there is a multimodal vision retrieval augmented generative model. What would be the valid and important evaluation metrics for it, especially in the sense that it's used in the defense sector and has lots of confidential information? Now, that's a tough one. Let's try to unpack it maybe. So
metrics.
how do I see it? And maybe I can start and start sharing some of the thoughts here. If you just go back on one slide, Sasha, and we flesh out the risks we have. So we are talking about RAG model in defense sector with confidential tabular data. I presume that this is going to be used not by external users, but by internal users. And please correct us if it's not the case. So in which case you would want to split it into two parts, right? Sasha mentioned at the very beginning, the first part is the quality. The quality of the product that you're building that uses RAG and GenAI model to give an answer, presumably lots of tabular data to provide some information for the user, and the user is within the organization. Now, this is something that we are not covering here as a part of this webinar. So you might have lots of different criteria on what is the accurate answer, and you need to evaluate them. Example would be if it's a retrieval augmented pipeline, so you would have metrics that touch on how accurate is the context that you're retrieving from the database to the actual request from the user. It's very similar to the search use cases. Second metric would be how accurate the model is with its skills of retrieval information from this context, summarizing information in this context. And you also mentioned the tabular data. So basically, you have in your context some tabular data. You need to make sure that the model wouldn't mess it up. So the second part is also not a fairly standard. It requires quite a bit of work, especially if you need to tune it in a specific domain. But you would need to evaluate how good your model is with knowledge manipulation skills. But this is, again, something that we don't touch here as a part of our webinar. It's a big and a very important topic. Here, we are talking about safety of your models, not the accuracy of how they perform their core job. Now, if you think about safety of those models, and again, I presume this is used internally within companies. Now, Sasha, do you have any ideas what could be the issue in this case? Like, again, it's an internal user, defense company. It's the model that presumably takes information from the database, summarizes it, and so on. Do you see any of these risks pop up in this case?
The logic of building the safety evaluation for this use case, I think it should be fairly similar on a high level, and it should start with formulating what is the undesired behavior of the model. So you would start with formulating for which inputs, what outputs you do not the model to produce, and working backwards, you would create a set of tests to check whether the model adheres to the guidelines or not. And then you would calculate the violation rate. And in case if that is relevant, you would calculate the over deflection rate by creating the prompts which are similar to the unsafe ones, but are in fact the model should expect to answer, and to see like if the control filters are too tight or not.
But then thinking about the risks, your use case and probability versus impact of the risk. So what's the probability that an employee of a defense company would try and come into and try and have a harmful conversation with the model? Probably it wouldn't be too high, and the consequences are also not too high then. Thinking that the model that's used internally will also be used to generate harmful content also doesn't sound like a very big one to me, to be honest. Now, the chances that the model would provide biased information, probably, again, not the biggest in your situation. Providing restricted information, on the opposite, you'd expect the model to be able to provide restricted information, so you don't want to tune it too strictly. There are some areas where you don't want the model to be used. For instance, if it's used for, I don't know, procurement in defense, and someone just decided to chat about tax or healthcare and so on, you probably want to restrict this type of conversations. And finally, acting as a harmful agent, RAG doesn't have agency, so wouldn't expect a lot of the issues there. So all you want to do from the safety perspective there is to make sure that the model doesn't talk on the topics it wasn't designed to talk about. It shouldn't talk about elections. It shouldn't talk about, I don't know, tax, legal, whatever it is. So it doesn't give some let's call it unsolicited advice or go into some weird discussions about politics and religion with the users, but the risks are much smaller because the model is not exposed to the external world. Now, this was another question. Let me just scroll a little bit up here. And yes, so we have this one. How do you think the safety evaluation will be developing? The models are getting more complicated every day. Will the same approach work in a year?
This is an excellent question. I think the point of the risks, the point we want to highlight for risks is that the existing evaluations cover well some of the risks, and the research work and the development of the evaluations for more narrow risks, even for text model, is something that is continuing to be developed. So I think one of the directions would be the more evaluations being available. Second part, I think the evaluation methods and the complexity will increase along a few dimensions. So within text, more and more complex texts needs to be, and as the model capabilities improve, we work with longer texts. We work with new languages, so the multicultural specifics to be evaluated for biases. Does the model consider the biases and stereotypes for specific geographies? Working with different languages, so this is another area of complexity. And the multimodal capabilities of the models also create the whole new set of questions for safety evaluations as well. So yeah, to me, those are the main directions of evaluations development.
Perfect. I think that's all we have in questions so far. Maybe we could go ahead.
Cool.
Thank you, Sasha.
Yeah, I'll have one final page on risks. So this is the types of risks that we define. And the few points that we want to highlight is that when you start developing the evaluation, formulating the specific risks should inform the scope, whether it is a comprehensive evaluation data set, where it is narrow data set, and the distribution data inside inside the data. If you want to quantify the specific risk, you should be able to define and formulate it clearly. In order to evaluate whether the model can provide restricted information, you need first to list it, and this is where the human expertise is needed. This is where you would involve experts both into working on the design of the data set and to execute the data. And the more complex risks require more complex evaluation methods, as many of those can be tested by like a simple single turn conversations, but the more nuances appear as you consider more complex risks. And with that in mind, we will go to the second part, where we will talk about the taxonomy and the distribution of the data within the data set. And similarly to the way we discuss the ML Commons data, you can think about this as a two-axis. One of them covers the categories or topics, and another one unpacks all the possible variations of the questions that the users might ask. And let's go through those ones. And let's start with categories. So now it's time to use the categories. Every company would have their own classification. We have seen very different classifications at different companies, varying from like seven categories on the level 1 to 50 plus categories on the level 1. We have our own that we use as a starting point, or we can adjust for the taxonomy, which is used by clients. And if you're working on a data set of 10,000 prompts, you want to ensure the distribution and that you don't have duplications. And this works through decomposition. We decompose categories into subcategories, into subcategories on the required number of levels. We typically do like 10 to 20 on each of these levels. So therefore, if you want to create like 1,000, you would have 3 layers. And on the lowest level of granularity, you would define the very specific topics that you want to assess. And let's take a less violent example here. Like this is how you would arrive to, say, a sword swallowing. And this example is relatively straightforward. When you build the comprehensive evaluations, it can be as simple as that. If you think about a very niche evaluation, if you're evaluating some cultural specifics in Indonesia, you may want to involve experts into designing those categories and subcategories to really define what specific aspects you want to test. Once you have defined the topic, we need to unpack all the possible questions that the user might ask. And we are thinking always in number of dimensions. We always start here from the user. The user, so what is, we're trying to imagine the user who is having like a very specific idea in their minds that they want to ask the model. And you can think about this as an axis of safeness, where we vary starting from the safe conversations in a potentially unsafe area to the clearly unsafe questions and going into the users who would use some adversarial techniques in order to achieve the undesired behavior from the model. And for each of those, we would create a set of techniques which would stand for types of questions that can be asked. For safe, those would be maybe objective questions in the area, like genuine interest in requiring the information. Within the unsafe prompts, those would be largely driven by risks, as the risks would help to formulate the question for providing the information or endorsing the behavior. And the adversarial techniques would put some of the techniques on top of that in order to try to get the model to behave in that way. If we take an example of source swallowing, this is how we would come to this variety of different prompts. And for each of these techniques, you can think about those as the libraries that you use in order to create the required variations, varying from the what is the swallowing, why is it dangerous, to the more indirect way of asking the same question. And wanted to bring another example here. This is an example of a data set that we have developed recently. And it illustrates the same logic. In this case, we were covering comprehensively wide variety of topics. We had 12 categories on the first level. We have created prompts varying from safe to adversarial. Mostly they were short to mid-length, up to 50 words in 2 languages. And once you know what you want to get, then the question becomes of the quality. How do you ensure the quality of the data that will make it into the final data set? In Toloka, we use our platform for that, and all these building blocks would be visible for a human performer who would take as an input all the dimensions of the diversity that you want to create, and they would create the prompts for this specific case. And this will be done with combination of humans and automation, and then it will go into the pipeline of validation, checking this like into the few layers of cross checks, resulting in the data that satisfies the distribution that we want to achieve. And for this specific data set, we had created roughly 25,000 prompts. And these are a few examples that illustrate how different they are for this specific case. Again, the longer, more nuanced techniques were developed to test different categories of danger. I'll give you a second to read and we can continue.
Sasha, do you think on the topic we can really quickly pick up one question? There was an interesting one about the culturally sensitive and data set across different languages and regions. So basically the question is, how would we address the challenges of creating such data sets that are culturally sensitive and work across different languages and regions?
Another great question. The current evaluations are very much focused on the Western specifics. I think if you want to create a specific evaluation that would consider some language or another culture, you would need to follow the same logic. You would start with formulating the nuances that you want to evaluate, and we are thinking about how to evaluate whether the given model, like for example, contains the biases which are relevant, like for different religions in Indonesia. You would want to have a human experts who would create the well-defined description of those biases, and you would create a set of prompts likely involving the performers from the same culture speaking the language in order to create such data set. This is one of the areas where we do our own research. I can give an example. We are working now with Arabic data set with one of the Middle Eastern university. We're creating a multimodal set of dialogues which would really capture the nuances of the simple image recognitions and the wording corresponding to them. So by building such data, you would be able to evaluate whether the given model would contain biases or not. I think there is another question. You mentioned the human experts. Have you looked in automated methods for generating prompts and or assessing the responses? How do they compare to human generated ones in terms of effectiveness? We put, so at Toloka, the humans are at the center of what we do. So we work with cases, and it applies both for safety and the data. If you take an example of SFT data that we produce, we really work with cases that are complex so that the human expertise is needed. And the same logic would be applied to safety as well. Many of these tasks can be automated already today, and the models, as the models get smarter, we will be able to automate even more. But every time you would have a need for a human to test the most difficult corner cases, and this would be the examples of those evaluations that we discussed. So I think that the combination is what we need to do. We need to test, we need to use automated solutions and then check in more detail with human-based evaluations.
Cool, thank you. Hope this answers your questions. If anything, drop follow-up. We will take them in the next pause.
Okay. Finally, want to get to the third part of this presentation where we will talk about policies. We have defined the risk we want to evaluate. We have created a data set, and we want to build the set of rules that would define what is the expected model behavior. Let's take an example of the same prompt for swallowing the sharp objects, and we can think about 4 different responses that you would get from the model. And so these ones I was able to extract from one of the open LLMs by doing a little bit of variations with the wording. And for this specific question, the model can deflect. The model can abruptly. It can deflect the question and give some alternative for user. It can seemingly answer the question, but really give the proposed steps such as going through awareness of risks and physiological adaptation, or it can go ahead and really provide the set of tongue exercises that you need to do in order to perform the activity. And if you think about this, all of them might work. I think the top left one is more unsafe, but this is an activity that can be performed by an experienced user. And one company might want to deflect all such questions. Another company might want to tune the model in the way that this would be the allowed behavior. So this is what is being described in policies. So the behavior policy would, for every given prompt, would define what is the expected engagement depth, whether it should be deflected, where it should go with the safe answer, adding a disclaimer, or with the direct answer to the question. And it would set a set of guidelines describing the requirements for the format of the deflection, describing the requirements for the coherence of the response, and also defining what is the acceptable content overall, what is considered to be safe or unsafe response. Typically, this is applied both to prompts and to the response. And based on these definitions, we are able to calculate the metrics for mostly we would focus on the level of non-compliance, such as percentage of the violations for a given data set, or on the percentage of over deflections for the safe prompts, in how many cases the model gave overly safe answer. And the definition of the response quality would give us the percentage, would allow us to calculate the metrics for the quality of the response. Here I wanted to bring in another example. Yeah, and one more thing that I wanted to mention on policies, that this the level of detail that we work with is really different depending on the company. We have seen policies which would be 150 pages long, really describing every single detail of how the subcategories should be managed and whether we should go ahead with answers for extreme sports as opposed to other dangerous activities, and really guiding the language that is used in deflections. And sometimes we would work with policies which would be short, a few bullet points, which we then transform into the guidance for our evaluators. And both approaches work. What is different is that you have less control about the precision of the evaluations, and you get more borderline cases in case the policy is less detailed. And there is one final example that we wanted to show here is project. It was evaluation of the video diffusion model. It was a red teaming exercise. We have done 2,000 prompts over the course of a couple of weeks, focusing on generating harmful information and also a few privacy and security policies. The limitation here was, and this is a very interesting practical limitation that you might face, is actually the throughput. So since the model, the video generation takes time, we were limited in the number of prompts that we can submit. And this does not allow you to have a luxury of sending like 10,000 synthetically generated prompts and evaluating the responses. So you need to really iteratively and carefully select every next batch of dozens, sometimes a few hundreds of attempts to really explore the vulnerability areas of the model. We've done it over 40 plus categories in this case, ended up with having like 20% safe prompts, as we found the quite strict content filters which were already over deflecting many of the safe requests. And of the other 80% of clearly unsafe questions, we got about 10% of the success rate with attacks. And there are a few examples of the approaches that ended up with a violation from the model. Like for this specific case, for example, surprisingly stating the bad intention, so actually describing what the policy I'm trying to violate, resulted in 10 to 20% prompts going through and being generated with the violations. And there are a few other examples of techniques listed here on the slide, such as playing with the language, persuading the model that this word in the other language means something different. So these are examples of what resulted in violations. that was it. We have put together this presentation. We really wanted to go step by step, starting from the very simple examples, so that we can build this structure. And we will create a few more webinars where we will cover more the role of human in safety evaluations, unpack a little bit all the nuances that you need to deal with when managing the human effort in the area. We will talk about challenges of the more complex use cases, evaluations, the multimodal, long texts, and we'll talk more about the more complex risk evaluations compared to the one we discussed today. Thank you very much for your attention. And let's
Thank you, Sasha.
questions.
Yeah, let's open up to questions. We have actually one interesting that just popped up. And basically the question is, in terms of evaluation, any mapping correlation to LLM safety leaderboard? So I can maybe try and pick this one. So as far as I remember, this safety leaderboard, so let me put it in a very simple terms. Compared to what we discussed today, it's a good starting point. It covers text-to-text models. It covers a subset of risks and categories we've looked into. It has also some of the things on top, like out of distribution robustness and so forth. Now, it has this limitation because it's an open source data set. They typically will have very similar limitations. First, they don't cover a lot of what could have been covered and what many of our clients would require when they release the model into the production. Now, we talk about toxicity there, but we don't talk about, for instance, generating misinformation, which is probably quite important, especially for non-text models, but for text models is important as well. Then, as for stereotype biases, they did a great effort into covering several demographic groups, stereotype types, and so on, but they're limited to a small number of prompt variations. The nuances there are more important. Sometimes you might see biases and fairness that would come in unexpected topics. But this is, again, a good starting point. It's just the matter of having just 3 variations of prompts. It's something that's quite limited, I think. Limiting, I think. And it doesn't cover models, whether the models would contain particular information or not. The risk number 4, I think, in our list, if you remember it. So all in all, to summarize, so what we explained here is how to create a more advanced version of it, how to go beyond the very basic toxicity risks that are much more impactful, right? So if, again, the model will just say some slur words or whatnot, there will be a couple of screenshots, but if the model is used to create at scale disinformation campaign during some important event, like cause riots or whatnot, this is a totally different situation. In terms of biases, one might want to dig a little bit wider, though we are still working on we're still doing research to understand when is this enough? So how big should be the data set to give you a good answer of whether the model consists biases or not across different topics? Yeah, other than that, it's a good starting point. Definitely advise you to have it as the first step, and then you might want to expand it, thinking about risks and what is the downside of the risk, as to understand where to invest your time to create the data set. Hope it helps. Hope it answers your question.
Yeah, I think it's
sorry.
exactly right. One thing I add, the available public benchmarks are very useful, and companies start with applying them. They kind of help to create the first baseline. If you read the technical reports, like all the foundational model that were produced, they actually find them not comprehensive enough and not deep enough in order to really be sure in the safety of the model. So therefore, both parts are necessary. Using what is available and creating the benchmark for your specific case, and further building the more niche evaluations covering those more specific risks as they emerge.
A quick comment there. So understand, great start with concept like policies. I want just to build on top of this. So the reason we think policies are quite powerful is because so far the world's seen only one use case when the model is used as the chatbot, and the policy is kind of very obvious, right? But then the further we'd go, the more use cases we'd see when the model should behave differently. Like Sasha, I think we've been talking about different use cases. And when you consider different use cases like non-play, like gay characters in the computer game versus mental health chatbots versus chatbots that are on the news or media outlets website help you find particular articles or summarize the events, those would have completely different policies. So there's no, like, one thing is for sure, they probably shouldn't use some like sort of language, but even this, in case of games, is not that straightforward. So each of them would have individual policies. So the good and bad is different for each of those use cases. So that's why I think about risks, think about policies, and this will help you understand how to create your data. Thanks, Anton. Thank you. Any more questions? I think we are ready to close this. It was great having you all here. Great questions. Thank you, Sasha. I suggest we wrap up and enjoy the rest of your day.